Howdy out there, this is Ed Doherty at Suncoast Technical College in Sarasota, Florida, and we're part of the Sarasota County school system. I am Ed Doherty and I'm the 8th year instructor here at Suncoast Technical College. Okay, first impressions. Our county bought 2 of these machines and they were meant to go to high school's engineering programs. We have 6 Techno Da Vinci roll-around similar machines to this that are laptop-based controls, and they're pretty much dedicated to only one project. It was called the TSA CO2 Dragster project. So they wanted to get into a better like tabletop machine. It wasn't as big, and they looked at some other brands and decided to try out the Haas because of our success using Haas machines in our technical school. And I've been working with everybody on the CO2 dragsters, so I'm kind of familiar with the CTE instructors. Plus, I realize it's not really a machine for our lab, but we want to be able to teach people how to make things, and not just additive manufacturing, but subtractive manufacturing. And also, if they have an interest, they can end up in our lab and continue to learn. And this would be good for us because it'd be like pre-training. Okay, so we had to do some little bit of like what's what on the machine. We realized it's ER11 collet. I looked that up. That's 1/4 inch shank. That's the biggest tool you can get in there. 15K on the RPM. I had 140 inches a minute. It's programmable RPM, so you can spindle override or we'll put in whatever you want in there. About 140 inches a minute, your max. We also had to write a little bit of a post processor there because you can do a tool change with an M6 code, but it's going to try to go to a position and think you're going to manually change the tool. We like to run machines in single block. When you do that, it actually goes into a sub-program section, so we decided to take the M6 out to not have that happen. But we do everything on the setups as far as manual setups. Okay, we did download the whole model into our Fusion, and I did that to see how much room we had. And I also designed a fixture plate and thinking of like thin, long parts, and also anything you can put in a vise. We also got a couple of slim vices that were very narrow, and that worked out pretty well. We just added a couple more bolt holes through these 2 that we bought so it would line up with the T-slots in the table. Oh, also you have to use 6mm T-nuts in these things. So I try to use 1/4 inch ones, and they don't quite fit. So, all right, we decided to do first project a Titan 1M made out of Delrin, and try to use one tool only, so we don't have to change anything. We do everything the same as Titan teaches us in his curriculum. We use Fusion 360, but you could use Mastercam. It really doesn't matter on this one. And here's a picture of every year we have. Every class makes a Titan 1M. We all take a picture with our new Titan 1M shirts. So Austin Dunk, the instructor over at Sarasota High, also made his Titan 1M. So we had to do our picture and send that out also. So right back there, we were able to make the part, no problem at all. Now on the Titan 1M, let me go back to the picture of the part. Of course, this vise was a little bit small. The long part of the vise is actually that vise is actually in the VF2. I was testing it out before I brought it over, and I wanted to compare how each one cut. But in the VF2, I mean in the DTM, I've been calling it, the desktop mill, it's longer in Y than it is in X. So you just want to be aware of that. I like that when I clamp on the vise, I like the vise to be facing me as far as the vise handle thing goes. It needs lighting inside. You want to probably put some like puck lights in there. It does not have an air blast, but we were able to cut no problem at all and not have anything clogged with the Delrin plastics. Mr. Dunk actually did another project on his own. We made this little coin out of plastics. I'm not sure what that is, but we have a lot of we got acetal and PVC and all kinds of stuff we can cut. We could do woods, and we're probably thinking we could do thin sheet metal kind of projects. Like if you want to make parts that you got, like an assembly of a box or something like that. I know Mark McCullough has a lot of good CNC router projects that he's lent to me. So this is getting pretty long on this one, but very successful. It's just a matter of learning how do you do your setups. We just did a slightly, probably in edited post, and just be aware that it's only 140 inches a minute. So if your post is spitting out higher RPM, inches per minute than that, you're going to get a warning that you're above the feed rate. So, but it's I think it's a very capable machine. I think the big plus is the Haas control, of course. Okay, talk to you later. Bye.